Okay, welcome to physics. I want to talk just a little bit about what the next little bit is going to look like for physics. Then I want to go over question 30 because there was a lot of you who said that question 30 was a problem. And then I want to do the next part of section 10.3. I'm also going to upload the PowerPoint to section 10.3 so that you have the notes on it. Looking at my notes over the next little bit, I have your tests. I'm going to mark them hopefully tomorrow and get those back to you. That's on my to-do list for tomorrow. And then I uploaded an assignment for you that's on chapters 9 and 10, and I said that that was due April 2nd. So that's going to work as like your unit test or your midterm, whatever. I don't care what language you use, but as your big test, that's going to count for that and an assignment. I'm going to have to play with the weights a little bit in terms of like, is classwork worth 20%? I actually think it's going to be more. But what I really need you doing then is every time there's an assignment in Google Classroom, even if it's just watching a video, please turn it in up in the upper right hand corner, just so that I know you're watching the videos, you're keeping up, you're doing what you need to do. Most of you are doing that, but there's a couple of you I'm not hearing a lot from. I keep saying that. Veronica, this is for you. That's it. That will count. So that'll be everything. So your marks are really going to come from your class mark, any tests that we did, and the big assignment that you're handing in on chapters 9 and 10. Before the end of this quarter, so before the end of next week, we should also be doing a test on section 10.3 and 10.4. I don't know what I'm going to do about theory yet. What I might do is do a theory test, but do it through Zoom. If you haven't done Zoom yet with any of your other teachers, it's basically something that businesses use to do meetings, online meetings. Unfortunately, the free version only lets us do 40-minute meetings, but for theory, if we just do the theory part, 40 minutes should be enough. So just let me figure that out. But before the end of next week, we'll at least have a test on the math part of section 10.3 and 10.4. And don't forget that assignments due. All right, so that's all the paperwork stuff. I want to look at number 30 on page 495 because a lot of you said that you were having problems with that. So it says you have a 64 kilogram painter. So he's 64 kilograms and he's standing 3/4 of the way up a ladder. The ladder is 3 meters and he's standing 3/4 of the way up the ladder. I'm going to draw a picture in a minute. The ladder makes an angle of 69 degrees. With the ground, what torque is the painter's weight exerting on the ladder? So if I was going to draw this, here's the ground, here's my ladder, and here is the dude. And the dude is 3/4 of the way up the ladder. He's not at the top of that 3-meter ladder. So the first thing I would do is I would get my calculator, which I've left downstairs. I'm going to pause the video just a sec. No, I'm not going to pause the video because I can't. Oh, look at that. My calculator magically showed up from my husband. All right. So 3/4 of the way up a 3-meter ladder. Let me make sure this is still recording. Yep. Okay. 3/4 of the way up a 3-meter ladder. So I'm going to figure out what 3/4 of 3 is. So 3 times 3/4. Whoops. 3 times 3/4 is 2.25. So he's actually, to him, from here is 2.25 meters, and he's making an angle of 69 degrees. Now it says what torque is his weight? Weight is the force of gravity, and force of gravity is actually working straight down there. Now remember, torque is lever arm distance times force, and we said that the lever arm distance is always perpendicular to the force. So the force is going up and down this way, and that's the force of gravity. And gravity is mass times acceleration due to gravity. So the force is the guy's mass, which is 64, times gravity, which is 9.81. Lever arm distance, we have to figure that out. But lever arm distance is actually this right here, because that is the part that is perpendicular to this. This is what R actually is. It is not the 2.25, which my guess is that's what you were trying to use. So first I have to figure out what R is. And if I know this angle, I want to know this side, which is the adjacent. And I already know that side is 2.25, that's the hypotenuse, so that is cos of 69 is R over 2.25. So 2.25 times cos of 69 is what R is. So R is 2.25 times cos of 69. And then I'm going to multiply it by my force. It should work out to be 506 Newton times meters, but we can only have two significant figures, and that is 3, so we round it off to 510 newtons times meters. Newton meters. All right. That is how you do number 30. I hope somewhere along the way you see what it was that you were doing